Good morning, friends. Welcome to VVSN Academy. 2021 SSLC examinations, question papers and answers for the 10th class revision. It also includes ICSE CBSE students of 10th standard as well as the ICSE CBSE student center school syllabus. Welcome, and we will provide science notes. Learn science, do science. 2021 SSLC examination question papers for 10th class revision is very important for the coming examinations for all science students of 10th standard, ICSE, CBSE, etc. So, discovery, cathode ray tube, discovery of electron tube, discharge tube, properties of cathode rays, discovery of electron charge, Millikan oil drop experiment we have discussed, and the charge of the electron by oil drop experiment. Now, coming to the atomic physics 2, discovery of anode rays. My dear friends, science, particularly atomic physics, Kanalstrahlen or canal rays, also called positive rays. These are positively charged ions. Eugen Goldstein, the scientist born in September 1850, Gleiwitz, Prussia, and he died in December 25, 1930 in Berlin. He was a German physicist known for his work on electrical phenomena and gases, discharge through gases, electricity, and on cathode rays. He is also credited with discovering canal rays. Well, friends, what are canal rays? Canal rays are the modified anode rays which is passed through the perforated hollow cathode. These are canal rays. These are the important thing. Anode Ray Tube conceptual view. He, the great scientist, German physicist, Eugen Goldstein. Eugen Goldstein discovered and he observed in Crookes tubes during experiments by the German scientist Eugen Goldstein in 1886. As I told you, Goldstein used a gas discharge tube which had a perforated cathode. When an electric potential or electric current is passed through the several thousand volts at high voltage is applied between the cathode and anode in the Crookes tube, in the cathode ray tube. He observed a faint luminous rays are seen extending from the holes in the back of the cathode. These rays are beams of particles moving in a direction opposite to the cathode rays, which are streams of electrons which move toward the anode. Goldstein called these positive rays Kanalstrahlen or channel rays or canal rays because they are produced by the holes or channels in the cathode, that is perforated cathode. You see, this is the perforated cathode, and the emission of this is called this anode rays. You know, what is the difference in the origin of the cathode rays and anode rays? Cathode rays are originate from the cathode, where anode rays are not produced from the anode. Goldstein studied at the University of Breslau, now in Warsaw, Poland, where he received his doctorate in 1881. His career was spent at the Potsdam Observatory. He was primarily interested in electrical discharge in moderate to high vacuums. In 1886, he discovered what he termed Kanalstrahlen or canal rays, are also called positive rays, as I told you. So this is The important, these are the holes and the perforated cathode rays, what we have discussed. So these are the important conceptual study of the discovery led to the design of concave cathodes to produce concentrated or a focused rays, which became fundamental to the numerous experiments in science and technology as of today. I would like to divert your attention towards the atomic physics further. The great scientist Rutherford's gold foil experiment. In the figure schematic gold foil experiment, in 1909, Rutherford discovered proton in his famous Rutherford gold foil experiment, bombarded beam of alpha particles on the ultra-thin gold foil and then detected the scattered alpha particles in zinc sulfide screen. This is the zinc sulfide screen. Most of the particles are undeflected here, scattered particles. This is the source of alpha particles from a radioactive element. The alpha particles are bombarding through this thin gold foil, which is the famous Rutherford's gold foil experiment, my dear friends. Most of the particles pass through the foil without any reflection. Some of the alpha particles deflect at small angle. Very few even bounce back, 1 in 20,000. This is the famous gold foil experiment of Rutherford's. In the atomic physics, the important things, detecting screen is observed here in the gold foil experiment. This is important. In 1911, Rutherford and co-workers Ham Dager and Ernest Madsen initiated a series of groundbreaking experiments. The experimental setup for Rutherford's gold foil experiment, radioactive element that emitted alpha particles was directed toward a thin sheet of gold foil. This yellow sheet is called a thin sheet of gold foil, my dear friends. Observe the figure carefully and you can see the surrounded by a screen which would allow a detection of the deflected particles. Most of the atom's mass and its entire positive charge are conformed in a small core called nucleus. The positively charged particle is called proton. Most of the volume of an atom is empty space. The number of negatively charged electrons dispersed outside the nucleus, same as number of positively charged in the nucleus. It explains the overall electrical neutrality of an atom. The conclusion of the Rutherford's gold foil experiment, according to the plum pudding model top, all of the alpha particles should have passed through the gold foil with little or no deflection. Rutherford found that a small percentage of alpha particles were deflected at the large angles, which could be explained by the atom with a very small, dense, positively charged nucleus at its center. Based on his observations, Rutherford proposed the following structural features of an atom. Most of the atom's mass and its entire positive charge are confined in a small core called nucleus. The positively charged particle is called proton. Most of the volume of an atom is empty space. The number of negatively charged electrons dispersed outside the nucleus is the same as number of positively charged in the nucleus. It explains the overall electrical neutrality of an atom. So this is the concept of the Rutherford's gold foil experiment. And this is the two great persons. Ernest Rutherford is the person. Left was awarded Nobel Prize in Chemistry in 1908 for his work in radioactivity. Well, this is another great scientist, James Chadwick, on the right, a student of Rutherford and Nobel. He won the Nobel Prize in Physics in 1935 for his discovery of neutrons. So, my dear friends, we have studied about the subatomic particles of an atom, that is the important is electron, protons and neutrons. In the forthcoming class, let us study about the discovery of neutron by James Chadwick. Thank you for listening. If you like our BBSM Academy classes conducted by Veerabhadraya Demaya, please call cell number 9663828428. If you like our videos, like, share and subscribe. And don't forget to press bell icon. Please subscribe, sir.